and we'll begin. I'm Michael Walsh, Chairman for the second session on the last mile or the campus LAN or whatever we'll find out during this session. We have two speakers, and then we'll follow up with a discussion between some of the speakers from this session, the previous session, and those of you within the room who wish to participate. Our first speaker is Ted Hans. He's the Director of Applications Development for Internet 2. He's going to speak on the Internet 2 End-to-End Performance Initiative, which he has been shepherding from its beginning through to the current stage. Ted, over to you.
Thank you, Mike. Your turn. Okay. Thank you, Michael. The first objective here was to compete with Delta in terms of the length of the title. So I haven't actually looked to see how many more bits we have here. But I want to talk about the Internet 2 End-to-End Performance Initiative. We're really talking about why, even with the focus on fat pipes, that end users are not necessarily always satisfied with their applications. So the vision for this initiative is that campus users, the faculty, students, and so forth, have routinely successful experiences in using their applications, both building them and deploying them. And you might ask the question, isn't that what advanced network activities such as Internet 2 are all about? But the reality has been this focus on circuits. And my role, again, is focused on the applications area of Internet 2, but we also have a major focus in the engineering and networking area. And how can we move the focus on circuits over to applications performance? Well, the context for this is that we do have the type performance backbones. I mean, we're going around numbers of OC48 and OC192 and OC768. And in fact, imagine you are a faculty member, you're sitting at your desktop and you want to do HTTP across the network. Well, in certain situations, under certain phases of the moon, the right machine, the right operating system, you can actually experience all the benefit of the high-performance network. The reality, however, is that most of us, a lot of the time, experience a gap between the reality of the network that it can provide and the potential of the network. The more common situation is one of the faculty member sitting down at his or her desktop, hearing all this about OC48 and OC192 pipes and 100 megabit or gigabit Ethernet down the desktop, tries to do file transfer across the country and is getting about 3 megabits per second. And what they do at that point is often stop doing that application and go on to something else. They don't even bother complaining about it because, as we're talking, one of the problems here is knowing who to complain to. And we often find that 20 minutes of that experience leads to 2 years of avoiding the network. So how can we move forward with this? Well, what we do is characterize this under something called the Internet 2 End-to-End Performance Initiative. So to dive into this, let me just distinguish this, the use of end-to-end in many different contexts. For example, we heard Steve Beering's talk yesterday or the day before, where he talked about end-to-end, really from an end-to-end architecture perspective. Now, we're strong believers in the end-to-end architecture, but end-to-end performance is more of it overlaps with it, and that's what our focus is on end-to-end performance, which may have implications for things like caches and NATs and so forth in the way, but our focus is on the broad view of performance. And it really is truly looking at the end-to-end experience. Sometimes I feel a little lonely as the applications person here in discussions with the network engineers, where if they can resolve the problem down to the NIC, then the problem is solved. While I'm talking to faculty members who are looking at the application on the screen, they really want an eyeball to eyeball or eyeball to remote instrument experience to be satisfactory to them. So you look at all these different components that fall into this, we have to address these in an end-to-end performance initiative. That is from user perception all the way through the stack on the client operating system, through NIC, through the network, and then on to the national and international links. So we do have an user level, an application level, a network level that we have to address as part of this activity. And there was a fair amount of debate here whether this was a jack-to-jack initiative or whether it really was something we were trying to do down to the end user satisfaction. So give you an example of where the problems might be. And this came out in terms of the discussion where we want to target this. So for example, NASA, the Jet Propulsion Laboratory in California, did analysis of the performance-related trouble tickets. And they found that 60% of the performance-related trouble tickets were tied to one problem. Any guesses on what that problem would be? What is that? Well, but what specific things contribute to the performance problem? There's small things like, number 2 is rebooting the machine, so some kind of local configuration problem. But number 1, over 60% of it was related to duplex mismatches. And that's not the kind of thing that any end user, they have no idea what we mean by half duplex or full duplex, and they can't resolve that problem. But it's that kind of thing that we want to be able to, if we see that's easy pickings, and that's the kind of thing we want to be able to try and address. Well, what was the steps in this? We recognize this problem. We're building very fast networks, but we're hearing from faculty who are saying, they say Internet 2 is bad performance. And what does that mean? I mean, you look at the circuits, you say the circuits aren't busy. So we tried to put together this workshop that we held earlier this year with a number of participants, application people and engineers, talking about what it means to them when we talk about end-to-end performance. Each participant in the meeting had to submit a short white paper stating their position, and all these white papers are posted up on our website. A number of people also produced papers who weren't there physically at the meeting. And what this group did was charge a design team with putting together a document that we delivered in February and reported on at the Internet 2 meeting in March on what we should focus on in terms of trying to provide quality experience for the students, faculty, and staff on our networks. Well, the input really broke into 2 areas. One is the people infrastructure. How do you facilitate the support staff and the faculty and application developers in terms of bringing information to them, connecting them up with each other. And secondly, an infrastructure for actually looking at the network and getting some empirical data from the network itself. So the overall approach has a number of areas. Top of the list, education and outreach, bringing information, as I said, to people. There's also application enhancement, tuning applications to take advantage of the network environment. Another big problem with, as I mentioned with the FTP situation, is that they're not running tuned FTPs, and so the delay bandwidth problem gets in the way, and they just need to put an optimized FTP on their client machine. The performance measurement infrastructure, I'll talk a little bit more about. Operations coordination, I'll talk about. And then campus upgrades. And this is another area of debate, was what's the scope of this initiative? If you were here in an earlier session and heard Michael McRobbie talk about the campus at Indiana University, he talks about over $25 million a year being spent on maintaining the network. Well, some people, I come from the University of Michigan, they're talking about putting $40 million in just to upgrade it. And so if we talk about numbers like that, you're talking about a $10 billion project to upgrade all the campuses. And that scares a lot of people. And so we really can't talk about one of the success criteria as being having complete upgrades to every desktop, but certainly in terms of making progress in that area. And then many partners. Now, our role here is not to try and create new structures, not try and necessarily hire new staff, create new relationships and organizations just for the sake of this project. What we want to do is fill the gaps in the union of all these different activities and look where we're falling short. So, for example, take the measurement gap. The measurement gap is one here's how network engineers see the network. This is an image coming off the internet, the Abilene NOC website, gives you the performance going on at that point for various internode links. And this is how we can assert, the backbone's, there's no problem with Internet 2 because look at the backbone, it's not congested. But the reality is the user sees the network this way. And how do you bridge those two environments? So the first things we talk about doing is identifying the people who are out there who are interested in using the network and are supporting the people using the network. So trying to identify the network and application teams. In some cases, they don't exist. And so we're trying to do is, both the next step is actually developing what we're calling an integrated and distributed operational support activity. We're characterizing this as a performance evaluation and review framework. Now, if any of you saw the earlier drafts of this, it was actually called the Performance and Evaluation Review Team, or PERT. And the problem being, some people saw that name and thought that we were looking at hiring a core group of people who would travel around university to university as a team to try and address the problems on that campus. And that's not what it's about. The analogy is more like a CERT environment. But if you have people on these campuses who are already responsible for supporting the students and faculty, but there isn't coordination among the various campuses. We've been talking about applications and examples here. There's no boundary to collaboration with the faculty. It does span, on a global basis, universities, institutions from many countries. But we're not all each aware of what's going on our campus with the faculty working with faculty at other institutions. And how do we create the infrastructure that brings these people together? Simply creating, for example, mailing lists of people who might support certain disciplines and domain application efforts. We also want to create some websites where you put some of the best practices, war stories, and so forth. We even hold a series that we call campus scaling workshops in different areas around the U.S. And by moving the workshop around, we bring a lot more people to the workshops than traditionally go to Internet 2 meetings, and we talk about simple things that are, duplex mismatches, the tuned, optimized FTP, and so forth. These people are all learning for the first time many of these things that others have been taken for granted. And so you've got to get this information out to a broader community. We're also talking about doing things like implementing reference sites for interesting applications. Now, as an applications person, the most powerful network debugging tool that I've had over the last couple of years have been MPEG-2 encoding boxes. Putting those on a network is almost assuredly leads to some fire drill within the university to get people together to coordinate how they can upgrade a router or a switch and look at congestion and packet loss along the path of what people are trying to do an MPEG-2 based video conference. What we want to do is try and put up some reference sites in stable locations around the network to say that if you can get to this point, then you've isolated it from being your end network. But if we can't get to this point, that helps isolate the problem down. And by putting these beacon or reference servers around the network, we hope we can achieve this. And then measurement's going to be the major part in terms of building out a new infrastructure, both active and passive measures, doing ongoing baseline measures so you understand the status of the network at any one time, diagnostic tools to try and diagnose problems that are going on. And one of the concerns that come up is if we put this thing out here for the active measures, how do you avoid having this be a tool for denial of service attacks? And so there's going to have to be some kind of authentication authorization environment around this infrastructure. Let me give you one example. I had an idea that I've been calling building this tool called where this came from. An idea called the disambiguator. And for anyone whose English is not their first language, this is a word I made up. The idea is to basically do something called the finger-pointing tool. How do you isolate down to a problem in the network? Or how do you answer the question, I want to deploy this application, is the network even capable of deploying it? So before I go out and buy an MPEG-2 box for video conferencing, can I just test the network links and identify where the problems might be before I actually initiate an event or activity? So today, no one is able to obtain a complete picture of an end-to-end path for an application. No one can answer that question for me as an application user. So the idea, it goes back to, we have those measurement devices, add all those nodes on the backbone that tell me between internode links on the backbone, but not from a faculty member desktop to another faculty member desktop. So my idea is to create 1,000 of these shoebox-size units, auto-configuring devices. You put on a network, plug them into the Ethernet jack on it. It goes off, finds its host server out there on the network, gets the information it needs to get started, and with a simple web interface can tell a faculty member, yeah, you can run this application, or here's where the problem might be, or multicast doesn't get all the way to your LAN. And it found for me that every level of the network, including next to the faculty member desktop, we have a much better picture of how the network is performing or capable of performing. So it allows testing not just on an end-to-end basis, but also on all the intermediate paths. So who has to be involved in this? Well, obviously the campuses. The campuses are actually a focal point for this because this is where a lot of the investment and a lot of the challenges are. We also want to work with individual faculty and work with them in their discipline environments. So they build collaborations, understand their needs in the requirements of their field. The gigapops of regional aggregation points, international partners. There's a number of activities, for example, the National Science Foundation in the U.S. have funded, look at things in the support area like measurement from the National Laboratory for Applied Network Research, or the Web 100 project, which has been looking at a instrumented client operating system that gathers data about the performance that could inform an application so you can build adaptive network-aware applications. Corporate participants and federal agencies. Well, the staffing for this, what's the role of the Internet 2 organization itself? First off, we know we need to provide some support and coordination for this activity, so we've hired a new director who will be starting in June. We are providing a certain amount of core funding, $1.5 million this year, for facilitating the areas of communication and coordination, including putting together the website, various workshops, and other kinds of presentations. We're trying to do what we're calling performance days. I mean, right now I go around to various Internet 2 member institutions and do these Internet 2 days, which raise awareness of the potential for advanced networks. And next we want to go around and do performance days. That is, help support the supporters. Identify the people on campus who support the faculty in the development and use of applications, give them the resources they need, which is both information and link to other people, so that we can build this fabric of people coordinated activities around the network. Now, one of the ways we're going to get started next is we're calling these Internet Performance Initiative Call for Participation. And this is to try and identify the core applications and services we'll focus on. We've had this issue of looking at the scope. So one part of the scope was, do we solve the $10 billion problem of upgrading everybody on the campuses, or do we start identifying some core applications and core communities? And the answer was we look at some representative communities around the network. So a portfolio of some base applications and some application communities, such as a group of high energy physicists, maybe a group of music instructors working on master music classes. And these applications run as we want both UDP and TCP-based applications. So applications like FTP will be part of this, as well as things like video conferencing and other UDP-based video applications. We want these applications to exploit some aspect of the advanced services, not each one, but in the portfolio do so. So we can make sure multicast is deployed, that IPv6 is being used, that we actually have some applications that use hundreds of megabits per second in their flows, so that we can support the truly high bandwidth applications, and who do incorporate some of the middleware, again, so we can look at the path length analysis of performance. And we certainly want at least one international collaboration here. Again, when we talk about the adaptive faculty communities, they definitely span more than one country. So one of the things that we do hope is that when this comes out in the summer, we'll have had some input from the community in terms of defining this call for participation, but also have responses coming from the international community in terms of participating in it. So we'll also seek participants in some of the various work areas like measurement, such as the developing the case studies and experiences and the knowledge base that we're putting together. Now, some of the success criteria that we'll see, how do we know when we've actually achieved our goals, is one of the solutions we've worked on really have scaled to the fact that we can deploy these on an institutional basis. That we want to avoid a situation where we solve the problem for these 4 faculty, and the next time we want to solve the problem, we solve it anew from the next 4 faculty. So we ask by focusing initially in the first year on a core set of applications, 4 to 6 applications, and maybe a couple of hundred faculty in what they're doing, we want to be able to increase by an order of magnitude the following year and the following year in a way that builds on the previous experiences. That we really have the application users involved. Again and again, I hear from faculty members who said, I hear about this great advanced networking, I tried it, it didn't work, I'll check it back in a couple of years. We really want to make sure the faculty are using this network. And then we have sort of a symbol for what we've been talking about is doing this without wizards. That is, not requiring an expert at the other side of a faculty member who is using the network. The way to solve this on a scalable basis is not to assign a network engineer and application engineer to every faculty member. So how can we do this application use on a spontaneous basis? Not that, get everybody lined up and I want to do this on this day at this time and get everybody else off the network, which is a lot of discussions we do have, but actually use it on demand. And I should say that here that part of this is also managing the end user expectations. I mean, we run into experiences all the time where people say, faculty members say, this Internet 2 thing is great, but going to Amazon.com is still as slow as it ever was. Well, that's not our problem, but we do. But a lot of faculty members don't distinguish between what we're trying to do in terms of the research and education networking community and what they may be accessing out in the commercial marketplace. So we do have to manage expectations reasonably within the users. So where you can get more information about this is one is the website where we have copies of those white papers I mentioned at the beginning. There is a copy of the design document that we released in February that laid out the framework for this effort. The new director, Chairman Freeman, will be starting on June 4th, and she'll be available for communication. And what I want to do is just show you very quickly an idea of a tool that I started working on in the applications group last year. When faced with this issue of people want to deploy video conferencing, and they ask the question of, can I do it between this site and that site? And I go to the network engineers and I say, well, what can you tell me about the network? And they show the backbone map. And so a couple people in the applications group have been working on this is called the Pioneer Project. And what Pioneer does is provide an interface so that which would be dramatically improved. But the idea is to provide a web interface so that a faculty member can go up to a location, click on a site of where he or she may be, click on another site where they want to connect to, and then click submit, and it'll come back with performance information along that entire path. So something simple you can point a faculty member at, and they can go and look at that data. So this is being built on the iCurve infrastructure, so that it was using existing tools, but adding this invocation capability from the web pages, and again allowing the concatenation of different iCurve boxes along an end-to-end path. So anyhow, I think this presentation is changed somewhat based on what's up there on the Kerna website, and I'll make sure to get the updated version up there. And also, all my presentations are also at the appsetinternet2.edu/talks webpage. So, thank you, Michael.
Well, thank you very much, Ted. Now, we have the last section of our discussion of our meeting this afternoon is a discussion, but if there are any particular questions arising directly out of Ted's presentation, we should take them now. I think I see one hand raised at the back of the room over here. Akon Ferhan.
You were talking about core participation and international participation. When will that be over, and when do you expect an answer? And can it be an individual university, or will it be a national region?
Okay, so Egon is asking. Egon is asking whether the response for this, and when the response can occur and who can respond. The first thing is that the process has been stalled until the new director comes on. Once the new director comes on, we'll see much more communication from her in terms of specific processes. The timing of this is that probably once she comes on, we'll start communicating out in terms of defining the call for participation. Expect to see that in June. And then the actual call coming out itself later in the summer, I hope that we communicate all across the normal Internet 2 paths, including the MOU rep mailing list. And the responses could come either from NRNs, or it could come from an individual university that may have a faculty member there. But in doing that, we would make sure that the local, the campus organization is part of that regional network or national network is appropriate. So there wouldn't be any kind of surprise for an NRN that somebody in their membership is participating.
Okay, any further follow-up question? Okay, follow-up to your follow-up. Quick one.
Quick one. Do you have any more of the specifications of pinpointing concrete?
No, there's not any specifications of that. So anybody interested in working on that, that will be part of the specific projects. But if you're interested in this Pioneer project, which will be part of that, there's a web page which describes how it works, and so you can look at that.
Okay, thanks very much, Ted. We'll have plenty of time for discussion in the latter part of our session this afternoon, when I hope we'll get some heat and some light out of it. While the changeover has been done there, could I remind people in the room to turn off their mobile phones? I think I may have forgotten to mention that at the beginning. Thank you very much. The second talk this afternoon is another case study. We have Gerhard Schneider from the University of Göttingen, who is going to talk about the developments in wireless networking. Gerhard is a professor at the university and has been working in these areas for quite some time. And look forward to a very interesting talk here this afternoon.
Looking forward.
Right.
Any idea what it could be? Okay.
No, it looks like it.
Cisco 15.
Ted, I was wondering if your
notebook. Okay, here we are.
Your engine performance initiative could help us here, but I think we have it now.
Okay, ready to start. From macrocosmos, the Internet 2, down to microcosmos, the network. What we're doing is have a little bit of experiments with wireless networking. The motivation is as follows. First of all, we all know that the Internet is almost everywhere. It's at the desk, and we have our files, all the information, all documents. I'm not talking about Dreamland. You can try if you really want to, but it's possible. Everything is online, it's digitally available, and you can download it to your local machine and just look at things. And we all know that the laptop is the future working environment, and the number of laptops that are floating around here is just underlining that. Other portable devices will be added sooner or later. Palm Pilots are available in abundance, also this conference. And once you leave your office with your mobile equipment, you're facing an interesting challenge. Where's your nearest internet access point? May you use it? That's the other question. How many access points, as an example, do you find in this resort in Italia? I'm not talking about this one terminal room, but just look around in the city. How many access points do you really find? Suppose you have your laptop with you, you're pressed for some urgent downloads, whatever it is. You see what I mean. Another example, in your company, in your university, have you the right to access the internet everywhere on premises? Can you just walk into everybody's office and say, look, here I am, I've just had 2 megabytes off the campus network? In the meeting room, you just want to download your forgotten documents. Is the internet plug working? You want to read your mail in another department during the session break? What about that? Just challenges. And if you do, you have to ask for king or queen sysadmin. And if that person happens to be around, most likely you'll be told, well, not everybody's allowed on the network and you're a security risk and so on. So we're still dreaming of the internet, and we have multimedia options. Everything is there in theory, but as soon as you're 2 inches or make it 1 inch away from a network computer, it's really network never land. Nothing. And you're frustrated and use your mobile phone, which you've just switched off, and you're back to 9.6 kilobits at its best, so 10 years going back. Next motivation is the fact that student dormitories in Berlin, almost all the official dormitories, they're wired, mostly on fiber optics or 100 megabits. Some of them using ADSL connections. It's one of the top positions in Germany, it turns out. This is an official statistics, not done by me. And that makes dormitories very attractive for students. You have internet access from your bed, but from nowhere else. As soon as you leave your dorm, you're lost. Again, network never land. Private places, they're not taken into consideration. So, tough luck if you live somewhere else. You go to a library, and you have to take your own laptop with you. What do you do with it? Well, you use one of the public PCs if you're lucky. Well, in our case, we have several hundred public PCs. Then you download the information, you upload it to a server, you go home with your laptop, which you had with you, and download the information from the server. Rather ridiculous, isn't it? And when the weather is fine, as it is right now, you have to go back to your bed and surf, rather than do it outside. Well, I know we have a little bit of a display problem when you go in the bright sunshine like that, but this will be solved sooner or later. When you do that, you have a bad social image. The main problem is that in most cases internet access is still seen as a local phenomenon from your desk, from your workplace, and not as a global need. The Roman warrior wants to have the internet almost everywhere. And so my personal vision is to be always online at little cost and with high performance, which is pretty much realized here. You open the notebook, you have your card in there, and you're online. The question which is sort of interesting from a scientific point of view is what happens if you're always online? You don't have to do that tedious search for net access. Well, maybe the comparison is good, maybe it's bad. It's like either having to search for food on a continuous basis or just go to lunch and find everything there. Suppose that conference here and you have to worry about food. You would leave by 11, go shopping and other things. Now, since everything laid out, it's very convenient, you think about other things. It's the same with the internet. Acute ideas of analog situation is that Woody Allen film where this one character is in every bar, every pub just calls the secretary, look, you can reach me with that phone number. This now has been solved with mobile phones. That tells us, well, maybe we should go on the internet side in the same direction, not go mobile. We did some first experiments in 95, nobody really understood the need. And now finally we have a standard, and we try again. We started about almost a year ago, a bit more, with our first trials, and that what the press got out of that. From the garden into the internet. The apartment cell, that really was the catching thing. We got some experiences out of that. A wireless LAN makes sense only if it's available, well, more or less everywhere. If it's not just one building, but really everywhere. And everywhere means you have one global management and you have one global operation. In some sense, it's sort of the French Revolution. Not every citizen is equal, but all next citizens are equal. Because when the LAN is operated on a local basis, there's no point in bringing your LAN card with you. You're not on. It's just like before where sysadmin tells you, keep out. In addition, well, this is sort of getting in, especially, science happens to be everywhere. It's a science town. It's not just the university, it's a couple of Max Planck institutes and other institutions. So the buildings are scattered all over town, which is a nightmare for the networking people because you have to dig up roads and do all sorts of things. But once you've done that, unfortunately we did that a couple of years ago, now it's a dream for the operator of a wireless network because you have access points almost everywhere. doesn't cost much. In addition, most schools, well, all schools are actually online. We use either fiber optic in a few cases or ADSL, so that gives extra points of presence. And the basic design issue was not to go for a 100% coverage of a few university complexes, rather go for sort of widespread coverage so that you have a chance of finding coverage within a few yards, kilometers, well, who knows. And the trick behind is that, of course, wireless goes into every direction, not just the direction you want it to go, if you use the right antennas. So if you put the transmitter in a specific place, you do not only cover the internals of the building or the inside, but also the outside. A bit of advertising, data network for science and research, started in 1991, fiber optics based. It's just a number of institutions, so it's Max Planck and others. And just to underline or stress the importance of Bill's comments earlier today, when you have your own dark fiber, you can do a lot of things. And over to that Max Planck Institute, which way is it? Laser. In here, that's some 30 kilometers of dark fiber, and you can do lots of things without having to ask anybody. We started off with 10 megabits just because it was a quick thing. 2 days later we got to under 55, throw out to 80 and we put in gigabit Ethernet, not having to ask anybody. Just, 24 fibers, you do what you like, bandwidth is not the problem. This is the sort of layout. You don't see the topology. This is really down in the valley, and you have surrounding hills here. So from up here you can see down into the valley. The coloured buildings, that's university buildings. Well, it's not one of the oldest, it's not one of the youngest universities in 1734. It's basically two campuses we have to worry about. This is one, and that's the other, plus up here. One of the historical highlights, Gauss wasn't getting in, of course, and his observatory is still in operation. The oldest Institute for Geophysics with the oldest seismograph is still around, and getting was the site of the world's first data highway. Did you know? The Gauss-Weber telegraph in 1833 with an amazing 1 bit per second. When you look closer, you can see the wires from his observatory over the city, up the church towers. Even in those days, church towers were important to the other place, and it was rumoured that they sent their scouts or servants over to say, look, Master so-and-so is starting to telegraph again. Anyway, 1 bit per second. Now with the gigabit backbone, that's a lot more. And going wireless with the first coverage, that's 11 million times faster. I don't have to talk much about technology, you know that. It is unrestricted, it works in a 2.3 gigahertz range, and it's like a citizen band network. Everybody can use that technology. No guarantee for exclusive use, no guarantee for exclusive access, and as you know, the wireless network here has no security, so when you use it, change your passwords when you're back home. The range of that technology, this is dark red, which is hardly covered by the beamer, but I can read it. By law, it's the short range, you can use 100 milliwatts. You know that mobile phones have 2 watts, so that's nothing compared with mobile phones. And the long range things are down to 30 milliwatts. This is not a misprint, it's just regulation, trying to stop people from interfering with each other. So this is just a comment on mobile phones using a lot more energy. And the range, they tell us, is about 300 meters with the normal antennas. Typical antennas are reasonably invisible as compared with GSM, so you face less resistance about those mobile small things. Now the range, in fact, is using the right antennas up to 4 kilometers. Without tricks, special antennas, but legal antennas. Inside of buildings, that's where things go down, much less, could be 20 meters, could be 30, could be 300, depends very much. We have 11 megabits. Skip that, these cards, you've seen them before. The antenna is up there, that's the access point. But that's a real trick. Special antennas, I use that company, it's a German company. This is the Yagi type thing, which is the one we use, and get all sorts of amazing effects. To start that, you need money, and I shouldn't give this talk without thanking those who gave us the money. We got about 250,000 euros, equivalent in dollars, both from our state ministry, and that's the person who gave the money, and from the federal ministry, she's the ministry at the moment, to do some things with that and see what we can do. We were able to buy some 150 access points, some of them with a dual card, and that's very easy when you have a dual card. We put one antenna to the card for serving lecture room, and the other antenna on the other card we put it outside the building. And just have a bit of extra coverage and wonder how much this extra is. We bought some 250 cards to give them to students on a loan basis. They just give us a deposit, and if they do not bring back the cards, we get the deposit, otherwise we hand it back. Since the prices are declining, they probably bring the card back and buy a new one. It's cheaper that way. The acceptance of laptops are boosted when you buy a few laptops. So far, the laptops are for the power user, and most people think you get a real box, and when you can give it online to them, they probably go to laptops rather than big machines. The acceptance is quite good, especially when colleagues, that's the point when you see that the ideas were not that stupid, when colleagues start to show off the new infrastructures to visitors. And the right antennas, that's the trick behind. In here you see the university skyscraper. Well, don't laugh, it's a 13-story building, but getting into very low, 1-story, 2-story houses, that's about it. And therefore 13 stories, that's quite a thing, especially when it's down in the valley. I mentioned that when you have direct visibility, nothing in between, not even a tree, just plain view. 4 kilometers is no problem, you still get 11 megabits. And from up beside that skyscraper, this is the view, and you see almost every single house. You can look right into people's bedrooms and other places. Another picture. All these balconies, they have clear visibility to that tower. Well, maybe that's enough, and indeed it is. You see students climbing on the top of their roof, putting that special antenna, and they're online. It's actually quite a surprise to us that this technology, which only covers 300 meters, can be used to really have a circle of 2 to 4 kilometers around a big, reasonably tall skyscraper. You don't get any connection or connectivity in the streets, of course, so when you're spoiled by using your mobile phone, it doesn't work that way, but it can reach people's homes. Next point is how do we operate that? Let's go for security concepts. First of all, access is guaranteed only to cards having a valid identification. What do we use? The MAC address, and we all know how secure MAC addresses are, especially in a student environment. They're top secret, aren't they? So basically that protects against a passing through visitor, but not against everybody else. We all know that the communication between the card and the access point is encrypted. We were not quite convinced that this is enough. Therefore, step one in the concept is keep the wireless network separated from our wired network. We use the fiber optic network on a VPN basis, so there's no interference, we don't need extra cables, but it's all separate. And we have one point where the two meet, and we do user identification using VPN technology at that point. When you use the right software, you have encrypted communication from your laptop. Not from the card, but already from the laptop, straight through to the gateway. And anybody can sneak in, tap the information, tap the communication, no chance. It is encrypted. We prefer scientifically approved encryption methods rather than the web which was designed for security by obscurity. Some committee, don't tell anybody. And as we know, early February, it leaked through that web was broken. It is not easy to break, but it can be broken. But given that concept that we don't care about the underlying infrastructure, keep everything separate, and at the gateway we do encryption, decryption, user authentication and other things. I think we're pretty safe. The access to the wireless network that way, via a gateway, could be a bottleneck. It's not. If one gateway is not enough, buy another, or a third, or a fourth. And Nokia is now offering that stockpile of gateways doing round robin. So when do we have to stop? 20 gateways? 40? 50? Depending on the number of users. We've got some 20,000 potential users. Right now we have a few hundred, and the current gateways are no problem. The backbone, again, is no problem. It's gigabit technology. So collecting all those access points and pumping them through the gateway infrastructure is no problem. And we can or could, well, this is sort of thing one has to face and to accept, about separate user groups. Certain faculties, they never adhere to computer center standards, so they want their own gateways, and they could buy their separate gateway, administer it, and be responsible for the traffic they let in. The advantage of that approach is it's relatively easy to integrate other user groups into that infrastructure without having to build the second and the third and the fourth similar infrastructure. And by that, you probably get more money. When you convince a company in the southern part of the city to join that network, they get a benefit because in the north they can use the university network. We probably could use their network in the south of the city. Nothing has to be built twice. And the gateways and encryption make sure that nobody can listen to the communication of the other groups. Measurement value, that's one of the bigger things. It's not Silicon Valley, it's much smaller, but many companies are there having to do with measurement, micrometers and other things. When you twist a big steel rod, they don't see a thing, but they can measure how many micrometers you actually bend it. It's quite amazing, you can believe it or not, but it works. There are local internet providers, and we have a city radio. It will be on pretty soon. The essential axiom, which I've sort of laid out, is that the wireless network is more than just a local network. So it's not an extension of the local area network of the physics department, of another local area network of the medical department, and so on. So it's not an extension of the old idea of a wired-based telephone system with a few decked phones that have a small range. When you go somewhere else, you're lost. But it's more an extension of the mobile world with the mobile phones that you have roaming. And I think this is the point where in most cases a design error is made. That you find a guru in some department putting up 2 or 3 antennas and another person in another department doing the same sort of thing, and users cannot roam. So you do need a centralized, not centralistic, this is always a subtle difference, a centralized concept, how you can cope with roaming requirements and maybe decentralized user administration, and I believe that gateway VPN technology is just the right thing to do. The target is that we have one wireless network, so we can really try on that internet always on, using the same rules, which means that somebody from the math department taking his or her notebook to the central lecture theatre does not have to find out about special rules in the central lecture theatre, because it's the same VPN gateway, no difference. This is just another slide which just highlights that. You find those many wireless LAN cells connected via a virtual backbone into the gateway, into the router, and only then it goes into the network. In some sense you might see we view our own wireless network as a hostile exterior network, just like the internet. Once you start running, all of a sudden you find new partners. That's the best part about the story, the local bank. It turns out that they have 3 major branches in the city centre, and they're all connected via fibre optics, and they have spare fibre optic cables. Now what is the reason? Why should they give it to us? Well, we do online banking, get new students as customers. They took the bait and we got the fibres. Siemens Fujitsu was all too happy to lose money on us, and they allowed us to sell 100 high-end notebooks at 1,300 euros, typically about 3 times as much. So it pays to be a student. The city itself, first of all, will grant us access to their town hall skyscraper, another 14-story building. So by American standards, you start laughing, it's probably just a tiny little shoebox, but on a sort of low, flat-built city, that's quite something. The city of Göttingen will now donate, you read that correctly, donate Wayland cards to students who take up residence in the city. Why would they do that? Has to do with German tax laws. The primary residence, the town or the city gets, I think, a bonus of 800 euros. So, by motivating people to register with the city rather than registering with their hometown, they get 800 euros and they might as well pay back 150. So the future working conditions, people sitting in pubs, clean office spaces, and people doing telephone calls, and that's the next sort of thing one is into. What's that guy's using? What about voice over IP? Why is that a separate phone? Does it have to be a separate phone? After all, we know that digitized voice is data. It's easy to say that here. This is not really understood in society, in parliament, in legislation. Voice is always something special and you can make money on that. Try to tell people that voice is data. We are experimenting with voice over IP. First of all, Siemens has a solution. It's basically a software gateway on a PC which you hook up to a PABX, and then you can have a gateway, voice over IP, LAN traffic into the proprietary telephone system. You can make real telephone calls from your PC. When you do that, occasionally you get a real blue screen, and you wonder about whether this is a real idea, because is it so good you can't call for help when you have a blue screen, when everything's on the same box? But when you have a notebook, you can carry it, and the idea is, well, maybe we can build our own mobile voice over IP phone. We don't have to. There's one manufacturer called Spectralink. They're already doing that. They're still pretty expensive, but it's a mobile phone doing voice over IP. It connects to the gateway, and you're in. This gives immediately rise to two very embarrassing questions. First of all, what about DICT? DICT offers roaming. Caretakers, technicians, they have these DICT mobile phones. They run around the university, you can always call them. There is, or was, a project about extending the university PABX with DICT. Well, when you can scrap that project, money is left behind, which you can use for a WLAN project. So that's the added motivation to that. Kill one and take the leftovers. Especially when it's called money, the leftover. And the second embarrassing question is, what about UNTS? Non-Germans may not know the figure, but in Germany, 50 billion, repeat, billion euros were paid for licenses, not for equipment, for licenses, by the telecom operators to get frequencies. It's just licenses, 50 billion. Divide that by the number of universities we have, we'll probably get anything between 10 to 300 million euros per university. Give me 200 million euros to build a wireless network. I don't know what to do with that money. Just bring that into proportion. Just imagine you get 200 million euros to build a wireless network. I mean, every tree has 2 antennas on it. And they have to earn the money. And they can only offer 2 megabits. And the waveline gives you 11. So you start to wonder about the bet all these telecos did when it comes to new technology. Now this is the sort of advertising slide, how everything goes together. Wire that wireless, and you have that split over into the 2 networks, just to show that the connection of the old world is possible. And as a summary, wireless is easy to install, just know it. It's a shared media, therefore it's no good. 11 megabits, that's the good old Ethernet with all its disadvantages, but it's there wherever you go. And we view it as an extension for the roaming user, not as a replacement for the existing infrastructure. So the cabling infrastructure is still expanded, but when you go to things which are reasonably old and you have to adhere to certain conservation laws, you better go wireless, only in these cases. In the future we'll see that in other cases you carry your computer with you, everything's wired. And the last problem that remains to be solved is increase your belt space to carry all that, and carry the batteries. Okay, so this is the overview. Wireless LAN are better than you think. That's our experience.
Thank you very much, Gareth. We're going to we'll take a direct question to this while perhaps the other speakers assemble, because we're going to have a discussion now about some of the issues that have emerged through these two sessions, this one and the preceding one. Any immediate question to the point for Gert? I see firstly at the back here and then at the front. Michael, would you like to come up and join us? And would you like to join us?
Okay. First off, you pointed out that you need a line of sight for the system to operate correctly, which essentially means that we can't use it in the Netherlands in our cities where the universities are. So
you can. Just climb on the roof. It's inconvenient, but when you have a skyscraper and control of your roof, that's the trick.
Otherwise, we have looked into that, and it's proved hardly impossible, only in very small amounts. So I was wondering, have you looked into other systems? You mentioned UMTS, which I agree is far too expensive, but we are also experimenting with GPRS, which is much cheaper, and the advantage is you have a nationwide coverage.
GPRS, I gave a talk last week, so I know the precise figures. A download of 1 gigabyte over the German science network costs about €1 for us. A download over ISDN of 1 gigabyte takes 34 hours and costs about €26. A download of 1 gigabyte over GPRS takes 3 days and costs €10,000. That's the currency. We have to live what the operators tell us. If I had my own private GPRS network, I could drop the price, but we are really dependent on what they'll do. And UMTS, given those €50 billion, will not be cheaper. So this is a real killer. I think they made a big mistake auctioning off those frequencies.
That's why we work together with a mobile operator, and it's a lot cheaper.
Yeah. When you can do that, but then GPRS, that's 40 kilobits, 50 kilobits perhaps. UMTS,
no, but it goes up to...
It goes up slightly.
But
I just say this is something they should be aware of, the telcos. Maybe when they drop the prices to a point where I can say, okay, it's cheaper than building up my own infrastructure, they win. But right now it's very cheap, put the antenna on, and you get sometimes, in some cases, and we're very fortunate, I must say, we have a valley, we have 2 skyscrapers, so this is not the standard case. But then all of a sudden you get big coverage by accident.
Agreed.
I think it's a very interesting debate between these different approaches, different situations in different places perhaps, and indeed the problem of the license fees, it's not only in Germany but in many, I think outside of the Nordic countries, it's been universally the case. It's a tax on future generations' use of technology. We had one other quick question. Do you want to go over and join us while we have this question?
How come the public became restless because of the antennas pointing in their bedrooms, as you said before?
This is the mobile phone operators. You know, they have these big antennas, and this is really a scary thing. And when you know that they blast 20 watts out of one antenna, and there are 5 or 6 or 7, that adds up to 100, and a microwave is 600, it's the same frequency, people start to get worried. But these things you don't see. But so they don't know.
They don't know, and this will find out.
This is no regulation, there's nothing involved in that, and we're not doing that officially to connect homes. It's a pure accident that they have contact from home. If the thing is, say, 2 kilometers away and it's 100 milliwatts, that's nothing. It helps that the range has been reduced, 30 milliwatts or 100 milliwatts over a wide area. And one mobile phone is more dangerous than the whole setup we have.
And this is a good example of the sometimes the misunderstandings by the public of the square law and a few other physical phenomena. Thank you very much. We're going to have a discussion now on some of the issues that came out of this afternoon's talks. We ranged over the high-level, national, international, and linked to the campus from Michael McRobbie, and we had a number of case studies on the regional and the local, and then the wireless. And listening to these, I've abstracted a few points which I would like to offer as possible points of discussion, certainly points of interest to me. On the campus side, I'm fascinated at the achievement that Michael has so far in the University of Indiana. I know through the 80s it was different. So question for me, some questions for me arise around how do you generate a vision on the campus in the university about what IT should be deliver, and then how one should do it. Where does one get the leadership, the strategy, then the funding, and then the action, and of course then the iteration around funding, action, and revising the strategy. So there's a topic there, I think. We heard about infrastructure services with questions of high volume access, high volume, high number of users, perhaps low capacity access like the University of Delft, issues of mobility, and I think we've already heard an answer on the future of wired networking there. It continues to be needed. Commodity research and teaching networking, which is probably the 10 megabit wired to the desktop, and then the e-science infrastructure, the 100 megabits to the gigabit, and the end-to-end performance. Then we have the problem of applications infrastructure. We have other sessions going on about at the moment on middleware, and it's certainly my understanding that we'll be expected to deploy middleware infrastructure within all of the campuses in order to be able to deliver the end-to-end services. That includes grid technology in many cases, multicast and QoS, and there are arguments about whether this matters or not, but it's there and we're going to have to do something about it. This is difficult. It's difficult for the people in the room next door to us here, and they're the experts. It's going to be a hell of a lot more difficult for us on all of our campuses. End-to-end performance really we haven't started there, or we're just perhaps starting there. And all of these constitute work in progress, not finished products which you can pour in and make work. They're work in progress. So then remember that an old phrase I heard many years ago, infrastructure is everybody's third priority, yet we need to do it now. We then have some discontinuities between the campus network and the NRENs and the NRENs and the international, but particularly I think between the campus network and the NRENs. And I'm quite interested to see the extent to which the Internet 2 initiatives are getting right down to the campus and developing liaison relationships there. And then there's security. Security is regularly mentioned but rarely addressed, and we have a particular problem in universities and research institutes of implementing some security in an open network. And how much, I don't know. And then the question of politics, it's pervasive. So there are just a few points I drew out of the sessions up to now. I think it would be interesting to see some differences between the US and Europe. We have a vice president for information technology beside us here. Do they exist in Europe, or is there a different sort of political structure within the universities? Is funding different? Do we get 10% of the university budget, or do we get 3% of the university budget? Who supports schools? Do they matter? Certainly they're included in Canada. Are they included anywhere else? And then the question of the campus and interaction. So I'd like to see who'd like to pick up any one of those points or anything else that's bugging you about this whole area. Can I offer a microphone to somebody? Go on.
About the school problem. It may be different from the US, at least from the German point of view. Schools and universities are two separate entities with two different ministries. Therefore, you always find a problem when one side says, okay, let's support the other. It's a flow of money between two institutions, and they're very sort of touchy about that. In the Göttingen case, it was just done and not mentioned, because we signed that contract with the city at some stage and said, look, let's just do it. Make sure we do not cross-subsidize, so lay out the numbers and the money figures, but otherwise don't worry about the technical details. Then you can go further. But typically when you start to talk with schools in Germany, you always find that the other ministry is very jealous about it. But this may be different from the US and Canadian situation, where education is probably more seen on a generic basis for a region.
Michael, would you like to comment on the school situation in the US?
Well, probably prefer to comment on some of the other questions, actually. Because the point about the school situation is that in the US it just varies enormously from state to state, and you've got the complication of private universities, large research universities, four-year colleges, private and public as well, and then school systems, some of which are heavily decentralised, others of which are heavily centralised depending on which state you're in. A federal Department of Education has relatively weak powers, in fact very weak powers compared to the European situation, and other more centralised systems as well, and no real federal body that organises the universities in any way. The closest, nothing organises the universities, but you have bodies like the NSF that fund research in universities. So the US situation is very, very different, vastly more decentralised. Regions like to sort of brag and say how much better they are, but I think in the US it's vastly more sort of complicated and difficult to get any coherency among these. Having said that, there is an initiative that Internet 2 is undertaking where the conditions of use for Abilene have been liberalised to allow networks within states that connect up high schools and four-year colleges and so on to connect to the Abilene network, provided they are sponsored by one of the principal connectors to the Abilene network. And this has really been a major change in the CIU. I sit on the Policy and Planning Committee that was responsible for making those changes, and this was about an 18-month debate from memory to actually get the conditions of use changed to allow this. But what it's going to mean is that in effect most of the networks in the states that connect up the schools and the K-12s and the four-year colleges and so on are all going to connect into Abilene as well, as long as they're sponsored. And that's one thing. The other thing I wanted to comment on, and this really replays a conversation that Michael and I had over wine the other night at the opening reception, is that I'm a professor of computer science, and 20 years ago at a previous university was one of the leaders of the struggle to destroy the evil Central Computing Organisation, and I think had the first network of Unix workstations and on the campus, and spent a lot of time arguing against the Neanderthals and troglodytes in the Central Computing Organisation, and sort of led the charge that led to a massive decentralisation of the campus I was then on. And of course that was a phenomena that the rest of us saw all over the country. And I think part of the reason that massive decentralisation took place was obviously the convenience of having power on your desktop, which is a great thing. But another reason was that there were no standards. So there could have been any one of half a dozen competing networking standards were being argued would be the dominant networking standard of the future, and there was a larger number of operating systems, and there was much more heterogeneity there. But a lot of that's gone, and standards have emerged in many ways, and there's really just only one networking standard, and operating systems are down to a very small number, and even key software packages in a whole range of areas from desktop applications through to enterprise systems have come down to either a standard or a relatively small number of competitors. And what that means is that after all that time, there's this a significant re-centralisation of information technology happening, certainly in the US. I don't know what it's like in Europe, but I'm interested to know if it's similar here. And that is exemplified through the fact that IT is now regarded as strategic in universities and tends to be pulled together under one person and one officer who's a member of the cabinet of the university and participates in all the major decision making of the university. The irony for me there is, having led the charge in one direction 20 years ago, now I have to lead the charge in the other direction 20 years later.
We had an intervention from Victor Rice, I think, at the end of the room.
We can hear you. I had a question to a remark, and
I think it's more a remark. I like the idea of Ted Hans on the end-to-end performance initiative, I think. We are doing the same work in Task Force NGN, that's the Terrain and Dante working group, so there is some interoperator work done between America and Europe already on that front, so we are going to continue that. But I think that certainly for that kind of work and the idea of doing something like a PERT, so some performance in emergency response team, I think the European continent should take that up. I think some time ago we did it also for the CERT, I think it was 10 years ago or something like that. Trainer took up that part to organize everything in Europe to get that structure up, and I think it is now time with all these big networks and users complaining still that we do something on that, and I think it could be something for DANZA to take it up, at least in Europe, coordinated together with the Americans. So that's a plea I want to do, that somebody takes it up somewhere.
Thank you, Victor. I would comment in addition that the RIPE NCC has built a box which it uses for not end-to-end but point-to-point timing and performance, which might be a reasonable model for Ted's project to look at.
Yeah, it's not the technical boxes, I think. It's the procedure, the people knowing.
Yes, indeed. I'm interested personally in whether there are differences within Europe and between Europe and the universities in the way we organize authority and money. I suspect there are. Are they sufficiently radical that the sort of approach which has been taken now in the leading US universities, can we learn from that in Europe and do things in any similar manner? I mean, Laura, would you like to comment?
Okay. Well, I think in Holland it's now a little bit coming that a kind of CIO should be nice, and I think a lot of people not on top structure do think it's necessary. But the political agenda is not yet so far that the CIO in Dutch universities will have a future and here. But it should be very nice, and I think a lot of Dutch visitors here are strong supporters for that kind of organization. Maybe I can say about school and university structure in Holland. It's a little bit worse than in Germany, because it is one department in Holland, but still two different networks, not interrelated in any way, and I think that's a shame, really.
Yes, there are various degrees of badness. Okay. Michael, yes.
I just want to make another comment. I visited a German university late last year, and I shouldn't say which one, not Göttingen, and Göttingen is also the University of Hilbert too, of course. But it was interesting there to talk to them about how they have IT organised, and there seemed to be a view that they have an IT operation. I was visiting a computer science department there. They have an IT operation, but it was kind of pretty much invisible, and I think, to be fair, they were treated a bit like sort of second-class citizens. They weren't particularly visible, and I tried to argue that this really was a group that the university needed to look at as being strategic and to build up because of the impact that it could have. And I think as far as we're concerned, the IT organisation in a university, its number one priority is service. It has to provide a huge range of services to the university community. That's its number one priority. But having said that, the scale of the investment that you can bring together when you aggregate your total IT investment in a big university, whether it be in Europe or the United States, is really significant. I think probably most European universities would find that their central IT investment, which is probably spread out over a number of different offices, were they to bring it together, is comparable to the figures I showed before. It's probably at the 5% level, 5-6% of the university budget. and the total spend over the whole university, including all the faculties, might be up to 10%. Now, you can leverage that 5% in support of the research mission of the university. And my office, which is not an academic office, so I'm also an academic, but most people in my organisation aren't academics, but I have a lot of PhDs, a lot of people with advanced degrees, a lot of people that publish. My office receives more National Science Foundation funding than our computer science department does, and most of the other information in fact all of the information technology academic departments in the university. We get more NSF funding. That's for a number of big projects, but the two biggest NSF projects on our campus are both funded in my operation, and that is an example of how you can actually leverage the investment of the university in information technology in support of the university's research mission. They're not treated them as second-class citizens.
I wonder, Alexander, could I ask you, the French situation, I really know nothing about how France organizes its education. I just know that it's very different from everywhere else. And I wonder, firstly, do you have any idea what sort of level of funding the IT function within the universities gets? That's my first question, and then I have a follow-up question. What percentage of the budget does IT get? Do you know?
I don't know.
It's on. Yes.
I don't have the percent, but as in Germany, we have two ministries for school and university, and it's completely separate. For our metropolitan and regional network, it's only for the university. So it is financed by the university, the region. In France, every 7 years we have an agreement between the state and the region called État plan région, which votes budget. We vote a budget, and this amount of money can be spread over the different universities of the region. So the university pay, the region pay. My infrastructure, the city, has some specific funds, so we can pay. But I would say about what you say. In fact, our project is really important that we could work together, because if you are alone and you want to build and to finance your own physical infrastructure, it's impossible. So if you want to construct an homogeneous infrastructure and to give the most the maximum services, you have to be together.
I'd like to pick one point which I feel personally is a major contrast between what's now happening in the US and what I think is still the case in much of Europe, and that is the discontinuity between the university campus networks and the NRENs, where whatever it used to be like, Internet 2 is now addressing the issue. I think in most of Europe it's probably not being addressed. I think the mission of the NREN stops at the boundary to the institution. Is this true? I mean, there are people in the audience from various NRENs around Europe. Is this true? Does the mission stop at the boundary of the university? Commented back from Surfing.
Yes and no, I would say. In principle, the mission stops because we bring the internet to their door and they have to deliver it further. We do two things to enhance their own network. First of all, we bring loads of video into them, and to be able to handle it, they have to upgrade their own network, which works pretty well. The other thing is we try to stimulate the development of their networks, for instance, by these access pilots we run, which Laura told about, with fiber to the dormitory, ADSL pilots, fiber to whatever, gigabit internet trials, things like that. But we don't want to be responsible for those networks. That's I think an important thing to note. But we need it, we want it, we try to stimulate them, but we're not responsible for it.
Okay. Ted, is this as new as I think as it appears to be? Because I have a recollection that way back when it was either NSFNet was starting or Internet 2 was starting, I can't remember which one, the campuses were required to invest a certain amount in order to get the connection, which was, focus the minds of the university management on the value of the wide area network and force them to invest.
Right. I played a bit of a devil's advocate when we talked about starting this initiative, saying that this is what Internet 2 is about in the first place, so we don't need an initiative. What in reality it's doing is in some ways rallying the troops around something that they did commit to initially, but need some encouragement and reminding of that commitment. Because the first thing out of when they joined was a major investment in connectivity, and that what we're trying to do is now make sure people are taking advantage of that. So it's not new in that it echoes back to the very first words of what the Internet 2 project is about. But we need to come up with mechanisms in order to put the spotlight back on problems. And the fact is that we honestly are disenfranchising some faculty. And so unless we are putting this at the top of the Internet 2 action list, we'll continue to lose faculty who are potential users of this environment.
Just make a comment.
Yes, a quick comment from Michael and then Olivier and.
Tim has been very diplomatic. One can actually add that the problem was that though these universities made the commitment to appropriately upgrade the campus infrastructure, there's actually no way of enforcing this commitment. So many universities, though they committed, didn't actually do it. And that's part of the problem, hence the need for them to be constantly reminded. And that has effect on some and maybe not on others.
Olivier,
no, I think what is new is the general. Is there something called? Okay. So I think what is new is the general recognition that the TCP/IP protocols especially on the long distance links, whether they are east to west coast, but especially the one going to Europe, you have major issue with the way the protocol is implemented, more specifically the congestion avoidance. And that's actually beyond having a proper local network infrastructure. It goes much deeper into tuning and having auto self-tuning TCP applications. And so we are still quite a long way from being able to make it easy to have a high-performance application. And now as the boundaries of the backbones, even in Europe, are increasing by big factors, we will also see the problem inside Europe. When we have these 10 gigabit links across Giant, we will have exactly the same problem, that there is no application because of this I would say faulty TCP/IP stack, which was never intended to be used at very high speed. We will face the same problem. Okay.
That's a further argument why the corporate members and partners need to be involved, because their operating systems have been tuned for the congested environment. And the way the slow start windowing and so forth, and the fall back to half the speed, this doesn't fit with the kind of infrastructure that we have. And then we're doing more and more UDP-based applications where there is no nice, properly behaved congestion control behavior. And so we have to figure out how we manage that infrastructure. And so I think this is why we do need the corporate members involved. And Microsoft, had a member on the Internet 2 design team down the two.
Okay, quick comment from Maro.
two comments. One, and you asked why it's so difficult to do university upgrades. I think that in Italy, still the university the technical part of the university is still a minority of the whole of the university. That means that when they need to decide where the money should go, it's divided in reasonable percentage, and computer networks is seen as a scientific thing, and then goes in under central budget. And for example, in Italy, but I think this is widespread in Europe too, the amount of students in the scientific faculties is lowering, is not increasing. And the second comment, I slightly disagree with the phrasing full TTCP implementation. In any case, I can load up to 800 megabit with a single PC with Linux, which is a very reasonable implementation based on BSD. So that means that 8-9 PCs can fully fill a 10 gigabit link. The problem is that when he talks about end-to-end, well, end-to-end is a very blurry phrasing in these days, in which there are a lot of boxes between, and I would like a final comment on this part, which is end-to-end is fine, but we very seldom have really end-to-end connections now.
That's true. Yes. I'm afraid that time has caught up with us. I had committed to finish on time. The buses will leave on time at 5:45 for those of you who wish to go back to your hotels or need to. And I'd like you to thank all of our speakers again, and have a pleasant evening.